All right, so this is going to be 7.1.1 simplifying trig expressions. I did want to just say I'm sorry I'm out sick again. I did not intend to be out 2 more days this week, but I just got really, really sick again. So if I sound bad, that's because I feel bad. So anyway, I'm hoping I'll be back. I mean, I will be back next week. I can't be out longer, but yeah, so hopefully you guys are doing fine and watching this video. I'm just realizing that this is spelled wrong. We're identities. Anyway, so we're going to be starting Unit 7 now, and hopefully your test went okay yesterday for Unit 6. And so as you can see, we're still going to be doing trig this unit. We're going to be working with expressions and equations now. So the reason we did graphs just now is like theoretically graphing, if you have an idea of a graph, you should be able to picture things about equations and expressions better. We'll see if that really is the case, but hopefully our this isn't a complete 180. Like hopefully we're still able to use kind of what we were doing before at some point in this unit when we start solving. But anyway, so we're going to start looking at some trig identities today. That's what that word is supposed to say, trig identities. Identities are just like equations that are true, like where the left side equals the right side. That's all an identity really is. And these are statements that are true about the trig ratios that we're going to use to simplify expressions. So there's basically a bunch of little like rules that are true about sine, cosine, tangent, all of those. So you should be getting a handout today of these identities, of mostly blank, but of a list of all the identities that we're going to learn this unit. And so I'm switching over. I went ahead and filled out the ones that you're going to be using today. So the rest of them we're going to fill out kind of as we go throughout the unit. But I gave you the simplest ones, and we're just going to practice relatively simple equations today, or expressions. So the first set, the reciprocal identities. Now I know this page looks like a lot, but I bet you that the ones we're going to be talking about today, pretty much you already know, if we can think about the unit circle. So the reciprocal identities, I'm sure we already know, right? We know that sine is the reciprocal of cosecant and vice versa. So like technically there really is a vice versa one too. Cosecant is the same as 1 over sine. So these just say that we can switch from sine to cosecant by taking the reciprocal, and we can do the reverse too. So it may be good to think about it both ways. So we can always convert secant into cosine, we can always convert cosecant into sine, and we can always convert cotangent into tangent. In fact, the one that I've written underneath is probably the way we'll use these the most. Okay, but I think we know that already. We know, I mean, by definition, those are just reciprocals. The quotient identities, you may not think you know these, but you do, because we know tangent on the unit circle is y over x, right? So really all of this is just the same stuff we've learned on the unit circle. Tangent is y over x, which is sine over cosine, right? So tangent is sine over cosine, which is y over x, and then cotangent is cosine over sine, which is just the reciprocal of tangent. So these are our identities that allow us to convert tangent or cotangent into sine and cosine. Okay, then we have our Pythagorean identities. And these identities are about, obviously, Pythagorean theorem. And I want to point something out here. When you see sine 2 theta like this, what that means is it means sine theta squared. So it means the sine of theta squared. That's what that means. The reason the 2 is being put where it's being put is so that we don't get confused of, like, if we put it like that, it looks like the angle is the thing that's being squared. So we put it where it goes, is we put it in between the theta and the sine just to make it clear it's the sine value that's being squared. The sine of theta is being squared. So again, this means sine of theta all being squared. That's it. So don't get confused by that. That's just sine of theta squared. I'll just say sine squared probably and cosine squared. And this just comes from same thing that we knew on the unit circle, which is that y squared, because we can think of sine as y, plus x squared has to equal 1. I like to think of things in terms of x and y in the unit circle. And so that's not new information. And why is it called the Pythagorean identity? Is because that's just like on the unit circle, you know, our angle looks like that, and we can build that right triangle where this is the sine and this is the cosine and this is 1, and so x squared plus y squared has to equal 1 squared. Okay, now the other two are harder to remember. Like this one we should be able to remember because it's just sine squared plus cosine squared equals 1, x squared plus y squared equals 1. So we should all know this one. At least we should know it pretty soon. The others come from that one. So I don't really memorize these per se because I can always derive them again. All these just come from that first one. So if I take the first equation and I were to divide it all by cosine squared. So most of these identities are going to come from other identities just by doing something to both sides. So if I were to divide everything by cosine squared, I'm going to get tangent squared here because sine over cosine is tangent. I'm going to get 1 here because I'm going to dividing cosine squared by itself, and I'm going to get secant squared. So you can see this is the same identity, just having been divided by cosine squared on both sides. So it gives us one that relates tangent and secant. And then the next one is if I were to take the first equation and divide it by sine squared instead. So sine squared, sine squared, sine squared, and that would give me this one. And why do we have all three? Is just so that there is an identity that we can use anytime that we see something being squared. So any trig ratio being squared is always replaceable by something else. You're going to see that we're going to use these identities to replace things of equal value so that we can simplify expressions. Okay, so those are the identities we're going to be working with today. Just those, the reciprocal, the quotient, and the Pythagorean. So let's get into it. That's not us. This is us. Okay. All right. So this is a topic that students sometimes struggle with. I think it's just because sine, cosine, tangent looks scary, but they're just essentially variables. So all we're doing here is just simplifying expressions with variables. I can't give you a one thing to do all the time, but I can give you some tips. So my first tip is always my first tip. It's always nice. So if we're simplifying an expression, we want things to be alike so that we can try to cancel things out that are alike or potentially add like terms. So typically, and this is just because they're our most familiar, I will say rewrite your expression in terms of only sine and cosine. We are most comfortable with sine and cosine, and we have all these identities that relate other trig ratios to sine and cosine. So that's usually a helpful tip, is if you've got anything in there that's not a sine or a cosine, find an identity that you can use to switch it into a sine and a cosine. So what I'm talking about here is in this one we have a tangent. And so I'm not sure where I'm going. You aren't going to know where you're going with this, but look on your identity sheet and find a identity that converts tangent or that relates tangent to either sine or cosine or both. And so if you skip and you try to figure out what relates tangent to sine and cosine, hopefully this is the one that you would identify. Okay, we have this quotient identity that says that tangent is sine over cosine. So I'm going to take my tangent and replace it with sine over cosine. Okay, I might not have space for this next one, so I'm going to erase it. All right, so now let's see where we're at. So we now have a little bit of math we can do. So I have now something that's multiplying where I can actually multiply and do something with it. So this is like a sine over 1 times a sine over a cosine. So sine times sine would make sine squared theta over cosine theta. By the way, I never really addressed the instructions simplify. What are we trying to do here? We're trying to get our expression as simple as possible. We're trying to do everything that we can do in the expression. So like we are supposed to eventually be able to add these two together. That should be the goal. And typically when you simplify, you're looking for maybe your answer to just be one trig ratio or one number even. So we have more that we can do potentially. Okay, another tip that I have that's going to apply right now is, okay, that allowed us to do something, step one. Now what we might be able to do is deal with our fraction. So we can add and subtract. So we have some adding that we want to be able to do. We can do that if we get common denominator. So if you get to a place where you don't see much you can do, but you have some adding or subtracting, you can add and subtract those terms by getting common denominator. Basically, we're dealing with a rational expression here. And just a side note, if you ever get confused here, you may want to just kind of think of this as x plus y squared over x. Do you know what I mean by that? That's like what cosine on the unit circle is x, sine on the unit circle is y. And so you're just working with a variable expression trying to get it simplified. Okay, so I'm going to multiply the left term by cosine over cosine so that I can get a common denominator of cosine. This is an example of my expression getting a little bit worse before it gets better. Sometimes that will happen, but you have to just go with the only things that you have to actually do in the expression and hope that it gets you somewhere. So I have common denominator, and now I can add my two terms together. Excuse me. Okay. And our goal is to fully simplify. So where could we go from here? We're trying to keep simplifying, keep replacing things of equal value. Okay, this brings me to tip number 3. Look for squared things. Because if we have squared things, we can replace them using the Pythagorean identities. That's why those 3 identities are there, is because that way if we have anything squared, we should be able to replace them. Now, really quick to those identities and make it clear that you don't have to have, like in this one, you're going to see, oh, we have this exact expression and we're about to replace it with 1. So we know from this identity that sine squared plus cosine squared is 1. But you don't have to have that exact expression. These identities are all rearrangeable. So like I could rearrange this identity into several different forms. So I could subtract cosine squared, and that's another identity. So this is just the identity as we learn it, but you could rearrange it and use it just to replace sine squared. You don't have to replace it exactly as it's written in the identity, if that makes sense. That might come up on our next problem. But anyway, so I see sine squared plus cosine squared. That, my Pythagorean identity tells me that that is equal to 1. So I'm going to go back and replace my numerator with 1. Okay, and then I am almost done. This is relatively simplified, but we would always choose to express this in non-fraction form. So I'm ending up with 1 over cosine, which is the same as secant. That is my reciprocal identity. So this whole expression is all just equal to secant of theta. And we can see that based on some identities that we can apply. All right, I'm going to do a second one. Why don't you try this one? See what you see that you could do to it. And keep in mind, there's always going to be different ways to go about simplifying an expression. So why don't you see if you can get this one simplified, and then pause and come back. Okay, so there are different ways we could go about this. So if I'm going about this, I'm going to identify, well, there's several things. First of all, my first tip said rewrite things with sine and cosine. I actually would not probably do that here. So you might be thinking, oh, we could replace, because we replace tangent with sine squared over cosine squared. So you can use that quotient identity, but squared, if it's tangent squared. But that's not really what I want to do, because I don't want to make a fraction where there isn't one. So even though I said that was my first tip, it's not what I'm always going to do. Sometimes I'm going to look for other things. What's jumping out to me here is that I have some squared things. So I'm going to look back to my Pythagorean identity and see what squared things could I replace. So I have tangent squared plus 1, and I know that that is equal to secant squared. And I have tangent squared plus 1 exactly. So that means I'm going to be able to replace that with secant squared. So I've got cosine squared times secant squared. So that was me using the Pythagorean identity because I thought to look for it, and I think of that anytime I have something squared. Okay, so now I know that secant is 1 over cosine squared, or we could even do it in reverse, that cosine is 1 over secant. I'm going to use it this way. I know that secant is 1 over cosine, so secant squared is 1 over cosine squared. And so now I can just multiply and reduce, and my cosine squareds are going to cancel out, and I'll be left with 1. Okay, and then just to prove to you that you can do things different ways, I'm going to work this one out a different way here. So another way that you might go about this problem, if you weren't sure, if you didn't recognize that Pythagorean identity right away, maybe you see the parentheses and you're like, well, I'm going to see what happens when I multiply. So maybe you distribute in the cosine squared. And then you're thinking, I'm not sure what to do, but I'm going to go off of Mrs. Campbell's tip of replacing things in terms of sine and cosine. So maybe now I see tangent squared, and I know that I can replace that with sine over cosine. In this case, sine over cosine squared. So that's the quotient identity. Okay, and now we have a cosine and a cosine that are going to cancel out. Leaving just sine squared. And now I can refer back to my Pythagorean identity, and that is equal to exactly 1. So either way, see there's two different ways you could have worked this out. There's probably others as well. Okay, why don't you take a minute, pause, try these, and when you get stuck, you can unpause and see what maybe I'm doing, and here's some tips, things I'm thinking about. All right. So, the first one, you may not know where to start, and that's fine. You're not always going to know. So I'm going to start by using that first tip, rewriting everything in terms of sine and cosine. So I have a cotangent that I can write as cosine over sine. That's the quotient identity about cotangent. I have a secant that I can write as 1 over sine. And I have a sine that I'm going to leave alone. Now, you're going to be reluctant to do that just because it makes it look worse. But this is actually going to get better. It's just that now everything is in terms of common. It's almost like they're in terms of common variables. So now I just have a rational expression that I need to simplify. This is a complex fraction, and we've practiced how to simplify complex fractions. So I'm hoping this doesn't look totally new. I'm going to multiply the top and the bottom by sine of theta. That's the lowest common denominator of all my small fractions. And this one doesn't have a denominator, so I don't need to worry about that one, but I do need to multiply it. So I'm multiplying the top by sine theta over 1, and the bottom by sine theta over 1, so that my sines there will cancel out. Sine cancels out, leaves cosine. So this is me simplifying my complex fraction. And down below, I'm distributing into each term. So sine theta times 1 over sine theta is going to give me 1. And sine times sine is going to give me sine squared theta. Now your other option here would be, instead of simplifying the complex fraction by multiplying by lowest common denominator, you could have just done the subtraction, get common denominator down here, and then combine them and multiplied by the reciprocal to divide. But if you remember how to simplify complex fractions, then this works better. Okay, so now, what are you thinking? I'm thinking that we have something squared. So I'm going to look for an opportunity to use my identity, my Pythagorean identity. Now, I have 1 minus sine squared. So I don't see 1 minus sine squared in any of my Pythagorean identities, but I do see that my first identity has sine squared in it. And I could either just solve for sine squared and just replace the sine squared, or I could look for ways that I could get 1 minus sine squared. So I see that if I were to subtract sine squared, then I would get this version of the identity that says that 1 minus sine squared is equal to cosine squared. So I'm going to go ahead and replace the whole 1 minus sine squared with cosine squared. So this is now cosine over cosine squared. And this is like having an x over an x squared, right? So now one cosine will cancel out from the top, and I'll be left with 1 over 1 cosine left on the bottom, and that is secant. Okay. All right, number 2, I'm going to actually add one more tip that is not necessary, but I think is maybe going to be the fastest to simplify this. So the tip that I'm going to add here is sometimes it is effective to multiply by the conjugate. So this is a trick I sometimes use when simplifying identities or simplifying expressions. So conjugates, remember, are like a plus b, a minus b. And the reason we do that is to make a squared minus b squared. So sometimes I'm going to do this just because I want to make squared things. And so this would allow us to do that so that things are replaceable. Because like if this, it's already all in terms of sine and cosine. So we can't do that. And I've got 2 fractions, and I have 1 plus sine. That looks sort of Pythagorean identity-y, but it's not, because it's not squared. So we can't just square it. Some people are going to think, oh, let's just square, but you can't do that. You can't just square a fraction without changing its value. But what you can do is multiply by the conjugate of that. So watch what I'm going to do. You would not have thought to do this, of course, unless you're told to, but hopefully once you see it done, you'll see why I'm doing it. So I'm going to multiply that second fraction by its the conjugate of its denominator so that I can make some squared things in the denominator. So I'm going to have cosine theta times 1 minus sine. I'll worry about multiplying that in later. And on the bottom, I'm going to get a squared, so 1 minus b squared, which is sine squared. That's just from foiling those together. Okay, now, what's the benefit in doing that? When we multiply by conjugates, we get squared things. We get a squared minus b squared. And squared things allow us to use our Pythagorean identities. So this is 1 minus sine squared, which we just saw me use in the last one, the Pythagorean identity. That's equivalent to cosine squared. So because I multiplied by the conjugate, now I'm able to replace that with cosine squared. Now the drawback of that is I also messed up the top, right? So I've changed the bottom, but I also had to multiply the top. However, now you're going to see why I chose not to multiply in this cosine yet. So see on the top, I didn't actually distribute because I was like, nah, I'm going to wait and see whether I want to do that. Typically, it's better to keep things factored. So right now, this top part is in its factored form. It's better to keep things factored because when we simplify rational expressions, we want to cancel out common factors. So now, because I left it factored, I can see I have a common factor of cosine, and I can cancel those out in that fraction. So that would leave 1 minus sine on the top and 1 cosine on the bottom. And this works out nicely now because now I have like denominators already. And so now I can combine my fractions. Add the numerators, keep same denominator. Like terms, sine minus sine is going to cancel out. And this one's also equal to secant. 1 over cosine equals secant. Okay. I've chosen kind of more difficult problems just to kind of give you some examples of different things I try in different situations. You might struggle through this, and that's okay. So you're just going to try things. So when you're stuck, you look for your identities and you say, what is something I could do? And you do it. You're not going to know where you're going. It's going to take you a lot of practice to know where this is going to go. Like, I could look at this and know where it was going to go, but you're not there yet. And you can't let yourself get frustrated if that's the case. So you just play around, and it's kind of a trial and error kind of thing. Sometimes I try an identity and it doesn't get me somewhere helpful, and then I just go back and try something else. So yeah, that's simplifying expressions, and hopefully you have this identity sheet because I'm trying to leave it for the sub. And I hope I will see you on Monday. All right, bye.